Dear students, an important part of physical chemistry, or you can say stoichiometry, that is the concept of equivalent weight and gram equivalent. You know, the term is new. We have idea about the molecular weight gram mole. Molecular weight you will get from a structure of molecule if you know the atomic weight. Molecular weight is the weight of Avogadro number of molecules. Atomic weight is the weight of Avogadro number of atoms. That means this molecular weight, its background is a molecule. You know, covalent molecule, there you will get isolated molecular structure, and the molecular weight term is important for covalent molecule which have isolated molecular existence. But for ionic compound, we will say formula weight. Since you know NaCl never exists as a single NaCl molecule, there you will get the lattice structure, crystalline lattice. You know that NaCl, better we could say it is formula weight. NaCl is nothing but the formula of sodium chloride by which we will represent sodium chloride, and the corresponding weight is the formula weight. That means formula weight is equivalent to molecular weight. Formula weight we will use for ionic compound. Molecular weight we will use for covalent compound which have isolated molecular existence. Molecular weight is the fundamental property of molecule. A molecule, its molecular weight is fixed, it is never variable. Even formula weight also fundamental, it is never variable. But a new term equivalent weight. Equivalent weight, a new term. This term will arise while a molecule or element will undergo a chemical reaction. Before chemical reaction, the equivalent weight term is meaningless. It has no meaning. If I ask you, what is the equivalent weight of H2SO4? The question is wrong. But the question will be correct if the question is, what is the equivalent weight of H2SO4 when it will undergo acid-base reaction with NaOH? That means the term equivalent weight arises when a compound or element will undergo a reaction, chemical reaction, then the term will arise. For example, in the redox chapter, second part of my redox or oxidation number video, then I have given so many examples, even of potassium permanganate. You know, manganese oxidation state plus. Molecular weight of KMnO4 is fixed, that you will get the molecular structure KMnO4. But the equivalent weight of KMnO4 is variable, that will depend on nature of reaction. That means to predict equivalent weight, you have to know the nature of reaction, that which you have to know the reaction. You know, reaction of mainly two types. You can divide it into two types. One is redox reaction. A redox reaction, when oxidation number decrease or increase will occur, or you could say electron may lose or electron may gain by someone, that you will get. Another reaction is non-redox reaction. Non-redox reaction. Non-redox reactions such as acid-base reaction. NaOH plus HCl, NaCl plus water. No one will oxidize, no one will reduce. That is acid-base neutralization reaction, non-redox reaction. Similarly, hydrolysis reaction also non-redox reaction. Double displacement reaction also a non-redox reaction. For example, you have taken 2NaCl plus calcium carbonate, CaCl2 plus Na2CO3. This is a double displacement reaction. No one oxidize, no one reduce, non-redox reaction. Major non-redox reaction are methylation reaction, and the reverse of methylation reaction is the hydrolysis reaction. But the important part of reaction is redox reaction. I will define the equivalent weight. First, In this part of the class, we will discuss first equivalent weight with respect to redox reaction. In the next part, I will discuss equivalent weight with respect to non-redox reaction. Now, I am going to explain how you will define equivalent weight of a redox reaction. Equivalent weight of a redox reaction. Equivalent weight with respect a redox reaction. You know, a complete redox reaction, that means there you get parallel oxidation and reduction. I'm taking a simple example. Iron solid plus Cl2 gas. I'm not being biology. You go put Oda FeCO3. Fe3 plus and Cl3 bias. See, get iron to iron 3 plus. Oxidation. Chlorine to Cl minus. That is reduction. And this complete reaction you can split into two different half reactions. Although practically half reaction has no importance, but theoretically you can split a complete redox reaction into two different half reaction. One half is oxidation half, another half is reduction. Now, the oxidation half, Fe solid, allow Fe3 plus 3 electron, due to 3 electron loss, and Cn2 gas plus 2 electron, you will get 2 Cl minus. Now, you got the oxidation half, this is reduction. You know, in any redox reaction, loss of electrons equals to gain of electrons. Since you know in a balanced equation, never you will get electrons in reacted side or in product side. That's why to do balancing, you have to multiply by 2, then you will get 6 electron. This you have to multiply by 3, then 6 electron you will get. And if you add this, you will get balanced equation like this. That is the another part. 2 Fe solid plus 3 Cl2 gas is 2 FeCl3. Correct. Now the question is, sir, why equivalent to it? Yes, see, if I write this equation, 1 mole Fe when oxidizes to FeCl3, there occurs loss of 3 moles of electron that you got from oxidation number 0 to plus 3. And 1 mole chlorine when reduces to Cl minus 0 to minus 1 for 1, you know oxidation number always per atom. 1 atom will take 1 electron to form Cl minus. Since Cl2 is a diatomic molecule, Cl2 take 2 electron for 2 Cl minus. That means 1 mole chlorine associated with 2 more electron transfer. Here 3 more electron transfer. That means 1 mole of any element or compound, their number of electron transfer is variable. That will depend on the nature of product. But equivalent weight with respect to redox reaction is the weight of element or compound, is the weight of oxidant or reductant. Remember, weight of element or compound, that element or compound may be oxidant or reductant per 1 mole electron transfer. Per 1 mole electron transfer. Remember this. Now I go. This is Fe. Its atomic weight or molecular weight, F. If I take 1 mole molecular weight 56 gram, then it is associated with 3 mole electron transfer. That means 3 mole electron transfer associated with molecular weight. Then 1 mole electron transfer associated with molecular weight by 3. When I will take molecular weight by 3, that 3 is called N factor. This is called N factor. This N factor is the number of moles of electron transfer per mole of oxidant or reductant. That means when you will take molecular weight by 3 amount in graph, that is weight corresponding to 1 mole electron loss. That is the equivalent weight. And equivalent weight is the weight per 1 mole electron transfer. 3 mole electron transfer is the molecular weight, 1 mole electron transfer is the molecular weight by 3. Similarly, chlorine, 1 mole chlorine associated with 2 mole electron transfer. That 1 mole electron transfer equals to its molecular weight 71 by 2. This is the equivalent weight of chlorine. That means you got idea about the equivalent weight. Equivalent weight is the molecular weight by a factor that is called N factor. That N factor is the number of moles of electron transfer per mole of oxidant or reductant. That means when you will take equivalent weight amount, that is called 1 gram equivalent. For example, here you know atomic weight of Fe is 56 and 56 by 3. 56 by 3, they are about 19 gram. They are about 19 gram. That means why you will take 19 gram Fe, then its corresponding 1 mole electron transfer occur. That means 1 Faraday, 1 mole electron transfer charge is 1 Faraday. So that 19 gram is the 1 gram equivalent of iron. If I say 1 gram equivalent of iron or 1 equivalent of iron, that is the 19 gram of iron for this particular reaction when iron oxidizes to Fe+. Similarly, equivalent weight of chlorine here 736.5 if it will reduces to Cl minus. If it reduces to Cl minus, that means when you will take 35.5 gram of chlorine, then corresponding 1 mole electron transfer will occur. The equivalent weight is the weight per 1 mole electron transfer. And if I change this reaction C, focus on this. If I write here, it is FeCl. FeCl. Then it is +2 oxidation state. Equivalent weight will be changed. +2. This is +2. And this is 2 electron. And this is already 2 electron. Don't you have to multiply by 2 or 3, both are 2. The simple reaction Fe plus Cl2, you will get FeCl2. See, here the equivalent weight of iron says 1 mole associated with 2 mole electron transfer. Your equivalent weight is equal to molecular weight by 2. That means equivalent weight is higher. Very hard to know in which species it will oxidizes or in which species it will reduces. That you have to know. For iron atom, its molecular atomic weight is fixed, but its equivalent weight is variable. That will depend on number of moles of electron transfer. Now I am going to give another example. The equivalent weight is the molecular weight by N factor for a redox reaction, where the N factor is the number of moles of electron transfer per mole of oxidant or reductant. See, you know MnO4 minus, I told you, MnO4 minus, it is a very good oxidizing agent, MnO4 minus. And its oxidation state plus. See, now when the medium is acidic medium, I'm not writing here complete reaction. Acidic medium. Then it will reduce us to Mn2+. Ma2+. You know, +7 to +2, they will get 5 mole electron accepted by MnO. That means 1 mole MnO4 minus associated with 5 more electron transfer. The equivalent weight is the molecular weight of KMnO4 by 5. And 1 gram equivalent is equal to molecular weight by 5 gram of KMnO4. Or you can say molecular weight is equal to N factor 5 into equivalent weight. Similarly, when the medium is feebly alkaline or neutral, feebly alkaline means pH less than 10 or 12 OH minus, it will reduce us to MnO2. Remember, MnO2. Here the oxidation number of MnO2 is plus C. So plus 7 to plus 3 electron transfer. That means when it will react in feebly alkaline or aqueous media, then here the equivalent weight is equal to molecular weight by 3. Another media we will get MnO4 minus when pH greater than 12, strong alkali, then it will reduce us to manganate ion MnO4 2 minus green color. Although MnO4 minus not exist in greater than pH 12, that is different reason. There you will get a spontaneous redox reaction. OH minus will reduces MnO4 minus to MnO4 2 minus, and OH minus itself oxidizes to oxygen. No external reducing agent required there. That's why MnO4 minus never exists greater than pH 12. Here see the oxidation number is plus 6 to 1 electron transfer. That means when it will undergo strongly alkaline media, that its equivalent weight is equal to molecular weight. That means the same species MnO4 minus. Its molecular weight is fixed, but equivalent weight is variable. If it will undergo acid medium, then equivalent weight is equal to molecular weight by 5. If it will undergo alkaline, feebly alkaline media or neutral media, equivalent weight is equal to molecular weight by 3. And while the media is strongly alkaline, then equivalent weight equals to molecular weight. I am giving an example. You have prepared a KMnO4 solution. Keep it to the bottle, and on the surface of the bottle there is the one student written is 0.1 normal. One student written 0.5 molar. Remember, normality comes from the gram equivalent. Molarity comes from the gram moles. Gram moles or molecular weight is the fundamental property of molecule. It is not here. Always do express concentration in molarity. Since its origin is molecular weight, which is fundamental at cost. Never do express permanently concentration in normality. Since normality comes from the gram equivalent, from equivalent weight, which is variable. If you are mentioning normality, there you have to mention the reaction. In which reactions respect its normality is this. That's why permanently concentration of solution never will write in normality. Normality will use just to solve purpose of the solve a stoichiometric problem. Temporarily we can use for a particular reaction, but permanently normality, the origin is gram equivalent or equivalent weight, never will express. Remember it. Now we are going to take another example. Europe Dichromate Cr272 2 minus orange color, and beautiful and important oxidizing agent in chemistry. It will act as only oxidizing agent. Remember in acid media, oxidation number of chromium here plus 6. When the medium is acidic, is plus medium, then always it will reduces to shear 3. See here 2 number of chromium atoms present. Here you have to write 2. Now 2 into plus 6 plus 12, 2 into plus 3 plus 6. That means it is a 6 electron. Cr2 1 mole dichromate will accept 6 electron to get 2 mole Cr3 plus, which is green in color. Now, molecular weight of dichromate had 2 number of chromium present. 1 mole associated with 6 mole electron transfer. Then 1 mole electron transfer equivalent to molecular weight by 6. So here the equivalent weight is equal to molecular weight by 6. And that you can predict if you know the reaction. For example, if I do oxidize Cr3 plus 2 chromate CrO4 2 minus or 2 dichromate, both are same thing. One is dimer, another is monomer. Cr2 7 2 minus. Now, see the oxidation number here plus 6, here also plus 6. Actually, both species are same. It is dimer, it is monomer. It will exist in alkali medium, it will exist in acid medium. Now here, if I say what is the equivalent of weight of chromium 3 plus salt, chromium 3 plus you will not get in market. Some salt you have to take there, chromium sulfate or CrCl3. Now, if you take CrCl3, what is the equivalent of plus 3 to plus 6? Add it to the m by 3. Now the question is, this is m by 3. Here also you got m by 3. Now question may arise, why it is not m by 6? Since remember, in which compound you want to get the equivalent? The chromium of CrCl3. And you have to see how many chromium atom present in that salt. Here is a what chromium atom, that's why I have taken one chromium, 3 electron dust. But here the equivalent weight was potassium dichromate. There are 2 chromium atoms, that's why I have taken 2 chromium. 1 chromium 3 electron transfer, 2 chromium in dichromate, that's why 6 electron transfer. The oxidation number decrease and increase will give idea about equivalent weight of different species. For example, in any reaction, oxalate, sodium oxalate or oxalate C2O4 2 minus oxidizes to carbon dioxide. That we get from oxidation number also. Here we get plus 3, 1 carbon 1 electron transfer. Since here is a 2 carbon, it is 2 electron transfer. And equivalent weight of oxalate salt. 1 oxalate is, if it is there, then m by 2. If there are 2 oxalate, m by 4. If there are 3 oxalate, m by 6. Now, ferrous oxalate I have taken. Ferrous oxalate. Take this example, ferrous oxalate. Now, in any reaction, I am writing here half reaction, not complete reaction. Only oxidation I have written here. Now, ferrous oxalate, it is Fe2 plus and this is 2 minus. You got idea? Oxalate when oxidizes to CO2, 2 more electron dust. Now, in any oxidizing, ferrous oxidizes to ferric lead and oxalate part oxidizes to 2CO2. Now, what is the equivalent weight of ferrous oxalate here? See, equivalent weight is equal to weight per 1 mole electron transfer. Then ferrous to ferric 1 mole electron transfer. And 1 mole oxalate oxidizes to 2CO2, 2 mole electron transfer. That is 1 plus 2. That 1 due to ferrous to ferric, 2 due to oxalate to CO2, that equals to m by 3. Now, both species you have to consider. Ferrous oxidizes to ferric, oxalate oxidizes to CO2. And you got the equivalent weight. That means when you weigh 10, its molecular weight divided by 3 amount, it is associated with 1 mole electron transfer. Now see, let any compound APS2, FeS2, iron biodide, let it oxidizes to ferric, ferrous part oxidizes to ferric oxide, sulfur oxidizes to SO. Remember this FeS2, iron with plus 2 state, and sulfur here separately I am drawing here minus 1. This is per sulfide actually. This is the actual structure of ferrous sulfide. Sulfur with minus 1 oxidation state. Now, if the question is what is the equivalent weight when FeS2 oxidizes to Fe2O3 and SO2, then what will be your answer? Since you know here Fe plus 3, that means E is equal to here molecular weight divided by 1 electron transfer. Both are oxidation, not oxidation reaction. Iron plus 2 plus 3, 1. Minus 1 to plus 4. Minus 1 to plus 4, time it 5 electron transfer. Minus 1 to plus 2. Per sulfur atom 5 electron, there are 2 sulfur 10, 2 into 5. That means it is m by 11 equivalent weight is equal to molecular weight of FeS2 by 11. By this way, you can easily get the equivalent weight of any element, any compound, when it will undergo redox reaction. But the criteria is you have to know the final product of the redox reaction. This redox may be oxidation, maybe reduction. A complete redox reaction, you can split into 2 different half, oxidation half and reduction half. I always saying a term transfer. That transfer may be loss or gain, both included in transfer term. That's why when you will split a complete redox reaction to oxidation half and reduction half, individually you will get the equivalent weight of oxidant as well as reductant. When you will take 1 gram equivalent of oxidant, that is associated with 1 mole electron transfer. If you take 1 gram equivalent of reductant, that is associated with 1 mole electron transfer. That means, loss of electron equals to gain of electron. If I take 1 gram equivalent of oxidant, 1 mole electron loss. If I take 1 gram equivalent of reductant, 1 mole electron gain. Don't you have to do balance? Always the reaction occurs. 1 will be cancelled out, equal. Always the reaction will occur by 1:1 gram equivalent ratio. That means any oxidant and reductant. If you take 1 gram equivalent of oxidant, 1 gram equivalent of reductant, then you will get product. No one remain in excess. And no reactant is in excess. No one is limiting. Then it is called titrating. Always any reaction occurs by 1:1 gram equivalent ratio. And that has important application in the stoichiometry, remember. That has important application in the stoichiometry. In stoichiometry is nothing but associated with a chemical reaction. One of the component of the reaction is known, other is unknown. The known component amount, if you were to convert to gram equivalent, then the unknown must be the same gram equivalent, since any reaction occurs by 1:1 gram equivalent ratio. Why not 1:1 gram equivalent ratio? 1 gram equivalent 1 mole electron loss, 1 gram equivalent 1 mole electron gain. The ratio is 1:1, but it is variable, depends on nature of reaction. For example, see, I am writing only oxidation, CrI3, Cr plus 3, IR minus 1. If in any reaction is chromium part oxidizes to, let's Cr2O7 2 minus, and iodine part oxidizes to let IO3 minus. Now see, the change of oxidation state or number of chromium is plus 3 to plus 6. That means equivalent weight, molecular weight divided by due to chromium. 1 chromium is there, that's why 3 electron loss. And for 1 iodine minus 1 to plus 5, 6 electron. For 3 iodine, 3 into 6. Since I am taking equipolar weight of CrI3, that means you got there E is equal to m by 21. That means when you will take its molecular weight by 21 gram of CrI3, then it is associated with 1 mole electron loss. By this way, you will get oxidation, you will get the equivalent weight of any compound or element, but you have to know the final product of the oxidant or reductant. Please student, wait for the next part of the equivalent weight. Stay with us. We'll get clear idea about the stoichiometry problem and so many different examples I'll give there. Also equivalent weight with respect to the non-redox reaction I will discuss little bit. Stay with us. Thank you.